Okay, so today we're going to talk about frequency distributions. So as you guys know, a frequency distribution is like if you're taking a survey and you go and tally the frequency of each response. So you could say like, what's your favorite sport? And you could say we have like basketball, we could have soccer, we could have football. And you go through and you're like, okay, what's your favorite sport? What's your favorite sport? What's your favorite sport? Frequency distribution is when you tally the results, that's 5, and that's your frequency distribution. Then when you put it into a table, you come through and you're like, okay, here's the tallies or whatever, and that means there's 2, there's 3, there's 5, so you can easily read it. That is a frequency distribution. Okay? So the steps to constructing a frequency distribution, the first thing you have to do is choose the classification. Like, what are we talking about? So for this example, it was basketball, soccer, football, like the different categories that you're asking about. The next thing you need to know is that those categories should not overlap, and they have to cover all possible values. So if I was using this right here, we said basketball, soccer, and football, this would overlap if I was in the UK and I said, what's your favorite sport? Well, soccer and football is the same thing to them. So that would overlap, that wouldn't work. Does that make sense? And it also has to cover all possible values. So if I'm going through and I'm saying, what's your favorite sport? What's your favorite sport? What's your favorite sport? And Jocelyn says cheerleading, well, that doesn't cover all the possible values, so that's not in there. Okay? Now, qualitative categories are really easy to identify. Like there's these answers, they don't overlap. Colors, like blue, red, green, whatever. Hair color, favorite sport, favorite food. That's really easy to keep separate. Quantitative categories can get messy because we can have so many values. That's where ranges come in to help with this. So like if you have a quantitative category for a frequency, let's say you're saying you're taking a frequency distribution of like weights at a wrestling meet, you'll see like ranges. So like if you weigh like 100 to 105.9, 106 to I don't know the categories for weights. Okay, that's where ranges come into play. Are we okay with that? Now, after you choose those classifications, you just have to count the number in each class. That's all a frequency distribution is. You have to figure out how many are in each class. So here's an example of it. It says, a small commuter airline in the West keeps records of complaints received from its customers. Complaints are listed in the following table. Find the relative frequency for each category, then answer the questions. So here's the type of complaint made by all the customers for this airline, okay? And here's the frequency. So 26 people said that tickets cost too much. 11 people said that the stewardess didn't provide blankets. Are we all okay with that? What they want me to find is the relative frequency. The relative frequency is what's the frequency relative to all of the complaints made. So we want to figure it out as a percentage. Are we okay with that? The first thing we have to do to figure out the relative frequency is figure out how many total frequencies we have. So let's get out our calculator, and the first thing that we're going to do is we are going to add all of these frequencies together. What did we get? 165. I'm going to come down here and put that at the bottom. I'm going to say that's like a total 165. Okay? Now with the relative frequency, we're just going to take each one of these frequencies and divide it by that total. So to figure out the relative frequency for the tickets cost too much, I'm going to take this frequency of 26 and divide it by 165. Okay? So in your calculator, you're going to take that 26 divided by 165, and when you hit enter, I want to remind you that it's going to come up as a decimal. But I like relative frequencies as a percentage. Okay, it's a percentage. So how do I turn a decimal into percentage? Do you guys remember? Move the decimal 2 places to the right. So I would take this decimal here and I'd move it 1, 2, which would give me 15.75. Let's round that to the nearest whole percentage. So what would that round that to? 16%. So I'm going to put approximately 16%. Okay? Then we're going to do the same thing with the next one. So stewardess did not provide blankets. That's going to be 11 out of 165. So let's put that into our calculator. 11 divided by 165. You get your decimal. We want to move it 2 to the right, which would be 6.6 repeating. And what would that round to the nearest whole percent? 7 or 6? 7. Good job. Not always. So if it was like 0.062, we'd go over it, and that would be 6.2%. That would be just 6%. Cool? All right, so what I want you guys to do is finish filling out the relative frequency for this table. So those of you watching the video at home, pause the video, finish filling out the table. Now when you're done, what you should do is you should take a second and you should add all of these percentages together, and what should they add up to equal? 100%. Now just be aware that we did a lot of rounding here. So you might be a percent or two off, and that's okay. So to make sure that you're doing it correctly, you go through and you would add 16, 7, 18, 20, 4, 16, 8, 7, 6, and you would want to get 100 or very close to 100 because we rounded, okay? Now what we're going to do is we're going to go over to the right and we're going to answer these A, B, and C about it. So first on part A, it says how many total complaints were made? 165. That was just taking our frequency and totaling it. Part B said what percentage of complaints were about the temperature of the plane. So if I'm going through, we have stewardess didn't provide blankets, schedules not convenient, plane often late, seats too stiff, airplane too hot, and airplane too cold. So there were 2 different complaints made about the temperature. So it says what percentage. So what am I going to have to do with those percentages? Add them together, and what would that give me? 24. Just a reminder, they're approximate, so we're going to put about 24%. Now on part C, would these categories be qualitative or quantitative? Let's answer that first. What do we think? These categories? Qualitative. Qualitative. Now some of you are probably like, well, what about quantitative? Because the frequency is not the categories. The frequency is just the frequency. The categories are qualitative. An example of quantitative categories would be something like your weight or your height, okay? What is the level of measurement for this qualitative data? Nominal or ordinal? Nominal, do we agree? Absolutely. There isn't really an order for these complaints. Okay. Now, frequency distributions can be displayed in a few different ways. Here's an example of a table. We turned that into the relative frequency. That's really awesome. Another very common way you're going to see it is bar charts. Now, bar charts can be displayed in a couple of different ways. You'll notice the first one, it's like a horizontal bar chart, and the others are the ones that we're more familiar with, which is vertical bar charts. Okay? So the first one is the lack of parental involvement, the Lewis-Harris poll, and it's comparing the percentage of frequency distribution to the response categories. Now I have a question. This is a percentage of frequency distribution. So do you guys think this is a frequency distribution or a relative frequency distribution? This one would be a relative frequency distribution because it's percentages. Be very careful when looking at charts like that. Now on this next two, we have sales performance, and they're comparing the sales percent with the total sales in thousands of dollars. These, they should be the exact same chart, right? Like they're comparing the same people, Susan, William, Beth, and Rob on each chart. Why do they look so different? Why do they look so different? Say that again? Yeah, but like, look, what did Susan make in this guy? Around a little under 200. What did Susan make in this guy? A little over 185. Okay. What did William make? 200. What did William make? Are they like the same numerical values? They're pretty close. So like, why, if it's the same data value, why do these charts look so different? Look at the scale. Where does this scale start? 0. And it's a little hard for us to see what Susan did in sales and what William did in sales. But if I look over at this guy, this one doesn't start at 180. So here's something we need to talk about. When you're dealing with graphs, okay, the scale alone is a huge factor that can impact how you guys see the data and how you interpret the data. So if they wanted you to be angry, if they wanted this to be a competition, and they wanted Susan to kick it up a notch, they would show Susan the second graph because it looks like she's way behind. But in reality, the first graph is more accurate because it's like, actually they're all pretty close. Susan just has like a little over 185, whereas the next person ahead of her is a little over 190. So be very aware of that. When it comes to accuracy, we prefer scales to start at 0. That just helps with honesty and transparency. When it comes to wanting to really see the data and really interpret the data, I think that it's best that, yes, we have the one that starts at 0, but then we also have the second one so we can zoom in and see more accurately. Does that make sense? So it's all depending on the scale. Let's go to the back page. Now the next kind of chart that we're going to talk about is a Pareto chart. I'm really not sure if that's how it's pronounced. Might be Pareto. I have no idea. Pareto charts. And that's just a bar graph who are arranged in decreasing order of frequency. So the people that like things in a nice order really like these kind of charts because the categories are qualitative. They can go in whatever order they want. So they put them in order from highest to lowest, decreasing order frequency. Stacked bar charts are something that are really hard to interpret if you don't know what you're looking at. So a really good example of a stacked bar chart is the Winter Olympics medal count in 2014. They have each country that medals, and then they have bronze, silver, and gold, and they're stacked on top of each other, so you can see the total at the same time as the individual. So on number 1, it says, according to the graph of Winter Olympics medal count 2014, so we're looking at this guy here, what country brought home the most medals overall? Russia. And that one's easy to see because it's the tallest graph overall. How many do you think they brought home? Yeah, about 33, 32, 33. That's good. Now on number 2, it says who scored more silver medals, Norway or Canada? So we're just looking at Norway and Canada, and we're just looking at the silver medals. Who scored more? And that one's really easy to see because the Canada one looks a little bit bigger than the Norway one. But if I were to ask you who scored more silver medals, Russia or Canada, would it be easy to decipher the difference? Not so much. Okay? Now the last kind of chart that we're going to talk about today is a pie chart. And a pie chart is a visual representation of the proportion between the part to whole. You guys have seen this. I know that yours is not color-coded, so make sure that you understand that this is what it's supposed to be. So here's what I did on mine. Since it's not colored on my sheet, I put Social Security is blue, so that's 38%. I just put it over here, 38%. Medicare and Health was 28%. It's just going to help us like decipher what's going on. National Defense was 16%. Other programs was 12%. And the net interest was 6%. Now, they're saying that they have a total spending of $3.36 trillion, okay? $3.36 trillion. And this is the percentage of how they spent it. So number 1 says, how much money did the government spend on national defense according to the pie chart? So what percentage of their funding went to national defense? 16%. But they're not asking what percentage. They want to know how much money did they spend. So what we need to do is take this $3.36 trillion and figure out what 16% of that is. Now, how many of you know off the top of your head what 3.36 trillion looks like written out? So let's figure it out. 3.36 trillion, 336, that would be 100, okay? That would be 3,000, 336,000. Then we have million. Then what comes after million? Billion. So this would be Okay, and then I think one more zero will do it, because that would be boom, 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 boom. So that would be 100, 1,000, million, billion, trillion, 3.36 trillion. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Now, if you're doing your homework and you're like, yeah, no, I can't figure that out. How are you going to figure that out? What are you going to do? Yeah, dude, Google it. 3.36 trillion, what is that as a number? Google it. That is okay. That's called logical thinking and problem solving. That's okay. Now, when dealing with numbers like this in my calculator, it'll work, but it's a little much. I'm going to turn that into scientific notation. Just a reminder, that means I want the decimal to come after the first number, so 3.36 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3.36 trillion is 3.36 times 10 to the 12th. Okay? So they said, how much money did the government spend on national defense according to the pie chart? So we're going to take that 16% as a decimal, so I want to take 0.16 and multiply it by the 3.36 trillion. So times 3.36 times 10 to the 12th. Okay, let's put that in our calculator. So 0.16 times 3.36 times 10 to the 12th. And your calculator is going to give you 5.376 E11. What does that E mean? Yeah, it's the same thing as times 10 to the 11th power. So that means I'm going to get 5.376 times 10 to the 11th, right? Now let's make that number make sense. Like, what does that number mean? If 10 to the 12th is trillion, what happens if I take off one of those zeros? This 3 goes this way, and does it stay a trillion? No, it goes to what? Billion. That means I'm going to have 5.376 billion dollars. Let's find out. That's a really good question. So if it's times 10 to the 11th, 5,376, so that'd be 1, 2, 3. So 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom. 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 You are absolutely correct. That would be 537.6 billion. Good catch. Okay, let's try it again. On number 2, how much money did the government spend on Social Security according to the pie chart? So how much did they put into Social Security? Okay, they put in 38%. So I want 0.38 times 3.36 times 10 to the 12th. What do we get back? $1.2768 times 10 to the 12th. And thanks to Mr. Shookman over there, let's double check before we write what that is, right? So I want to move that decimal place 12 to the right, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boom, 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 boom. And is it okay to say that's 100, 1,000, million, billion, 1.26 or 2768 trillion? Yes. So 1.2768 trillion. Oh, my pen wants to write today. Trillion dollars. Now, on your homework, are they going to give you numbers that are this complicated? Probably not. Okay, this is just the example that we had. Okay.